Recording started.
All right, hi ma9 students. We're going to do a recording here that's going to help us to review for the unit test that's coming up on December the 14th. So this unit test is going to include equations, which we've already gone over in our quiz before. We're going to go over some points on equations, relating to equations and inequalities that I'd like to just highlight a bit. I'd also go over that recording in that PDF file again and practice the questions that we had before in equations, just so you know equations really well. But this is going to kind of take equations and expand on it, and then also talk about polynomials as well. So first of all, before I do that, just wanted to reflect a little bit about Christmas, and just going to read some of the words here as well. I shared this in an email as well. So I really am thankful to God for Jesus as we look forward to the Christmas season. And what an awesome thing it is that the God of the universe would step down into human form and to come to earth in the form of a baby so we could be saved from our sins. And sometimes I remember I've gone to a place called Candy Cane Lane in Edmonton, which is a place where there's a lot of lights. You know, people do up their Christmas lights really in a really cool way. They really do it up on that street. And I always appreciate when I see these signs that sometimes people put up there as well that say Jesus is the reason for the season. I think those are awesome, and that's really important to remember as we head towards Christmas. I know it's important for me to remember. I know I can get caught up in the Christmas season, and of course, you know, gift giving is awesome, and I guess really that's what Jesus was about as well. God gave him as a gift to us, and so let's go from there and let's move on to the next page. Okay, so we got a little guy here. He's asking some questions, and let's review the concepts that students found a bit tricky on the equations quiz. So there are a few questions we're going to go over here, and so this way you'll be able to nail them on the unit test on December the 14th. I'm just going to get my little pointer here. All right, so the thing we want to remember here is that when we expand brackets, that's when we have a term outside the brackets and usually two or more terms inside the brackets. The thing that I highlighted in red text here is that it's really important to remember to multiply the term outside the brackets by both the terms inside the brackets. I noticed a few students had been multiplying the 3 by the x to get 3x, but forgetting that they also need to multiply the 3 by the 1 to get 3. Okay, so instead of this being 3x plus 1, when you multiply it out, it's going to be 3x plus 3. Okay, so again, this type of expansion is also going to come into play when we look at some more equations that involve this type of expansion as well. So we'll see that in a little bit. So here's an example of one. And so we can see we have to expand this. 4 times 2a is 8a. 4 times minus 3 is minus 12. So we get 8a minus 12. And this here should have been 20. I'll just cross it off and make it 20. Okay, there you go. So let's continue on then. So you can see then that we have 8a minus 12 equals 20, and you remember from the past that you want to end up with 8a on the left side. You want to end up with a variable on the left side. So you get rid of any terms that are with that variable first. So since you have minus 12, you're going to add 12 to both sides of the equation. You end up with this, and then divide both sides by 8. Okay, so we're not going to go into a lot of detail with the stuff that's actually the solving equations, but what we're really focusing on here is just the expanding of the brackets. So again, we're multiplying 4 times x to get 4x, and we're multiplying 4 times minus 2, and that gives us minus 8, so we get 4x minus 8. And again, on the right side, remember, we have to multiply the 3 times the x and by the 1, so it's 3x plus 3. Okay, and then we've got an equation like this. And remember, with this type of equation, since we have variables on both sides, we want to get rid of the smaller one first, so we get rid of the 3x. We subtract 3x from both sides, and we get x minus 8 equals 3. And then, of course, the first thing we're going to do at this point, or the next thing we're going to do, is to get rid of the minus 8. And that is going to involve adding 8 to both sides. Okay, so let's just kind of focus in on this point on equations that have to do with fractions in them. Remember, we always want to get rid of fractions in equations. And again, remember there's two different basic kinds we're looking at here. One is when we just have two fractions, and if we have that, we can cross multiply. So we multiply the 6 times the x plus 1 to get this here. We multiply the 2 times the x minus 2 to get this here. And then just like we were looking at in the previous page, we could expand this and then go from there. Then remember, this type here is different. We can't cross multiply because we don't have just one fraction on each side. And so because of that, we have to multiply both sides by lowest common denominator. Excuse me. And since 2 divides into 4, we're going to multiply both sides by 4. And you can see what happens then is here, you get 4 over 2 gives you 2x. 4 over 4 gives you just x. And then the 4 times 3 gives you 12. And then we carry on from there. So again, just pointing out the differences in those two types of equations that involve fractions. Okay, here's something, guys, that's really important. Remember, when you're solving an inequality like this one here, I mentioned that when you solve it, you treat it like an equation. But it's really important to include the actual inequality sign in your solution and also in your final answer. Okay? Because if you use an equal sign in your solution, you might forget to include your inequality sign in the final answer. So that's why it's good to include it all the way along. So here you can see that we have this part here, 3k minus 5. We want to get rid of the minus 5 first, so we add 5 to both sides. Then we have this. And again, you just carry on from there. You're going to divide both sides by 3, and you end up with k is greater than or equal to 2. Okay, on the next page we're going to highlight something else having to do with equations, and again, this one's also really important. When you solve an inequality, if you divide or multiply by a negative number, we need to switch the direction of the inequality sign. So that's something that's really important to remember. Let's just walk through this example here. So we can see we have minus 3x plus 1 is less than 10. We're going to add 1 to both sides to get rid of this plus 1. When we do, we end up with minus 3x is less than 9. Now we can see that what we need to do is we need to get rid of minus 3. So it's minus 3 times x. We divide both sides by minus 3. Oops. Remember, if we're dividing by minus 3, we need to switch the sign in the opposite direction. So we do that. Really important. So we're dividing both sides by minus 3. We end up with x on the left. And when we divide 9 by minus 3, we end up with minus 3 on the right. Okay, so what's the graph going to look like for x is greater than minus 3? And remember, this is only x is greater than minus 3. It's not greater than or equal to. So because it's just greater than minus 3, when we look at our graph, we're going to have an open dot, right? Okay, so it's got to be either this one or this one. It's got to be an open dot. And since it's greater than minus 3, it's going to be this one here. Okay. So here's another equation. We'll go through this one briefly, and we'll see which one of the graphs it corresponds with, the inequality. Okay, so again, we've got a 10 added to the minus 4t, and so we have to subtract 10 from both sides. When we do, we end up with 8 is greater than or equal to minus 4t. Now that we've got minus 4t and we want just t, we have to divide by minus 4. And when we do that, again, you can see we've switched the direction of the signs. And so we end up with t is greater than or equal to minus 2. Okay, so which graph is telling us that story? The numbers are greater than or equal to minus 2. Well, that's going to be graph A, right? This time we have a solid dot because it's not only greater than, it's also equal to. And we can see it's greater than or equal to minus 2. Okay, awesome. Just got a little bit of a cartoon here. This lady says, look, we have 10x plus 25 equals 75. Now 10x equals 50. Finally, x equals 5. And this guy says, but if x equals 5, why did you call it x in the first place? Good question, right? Of course, you guys know the answer to that. But yeah, it's one of those things you think about when you're first doing equations, eh? Okay, now we're going to make a little transition to polynomials. So, polynomials, let's talk about these different animals here. Polynomials, monomials, binomials. So remember, monomials mean they have one term in them, binomials are 2 terms, and trinomials are 3 terms. So when we're talking about one term, 5 is one term, but so is 5x, because when things are multiplied together, it's still one term. And so is 5x squared, because again, those are all multiplied together, and so is 5xyz. Those are all monomials. Whenever you have binomials, you have to have a plus or minus sign that separates the 2 monomials. So these two are monomials, but together they make a binomial. Again, 2 monomials, but the minus sign makes them a binomial. Okay, let's look at trinomials. So 3 terms in all. 3x is 1, 2y is another, 4 is another. Here again, this should be 5a squared, that's 1 term. 3xy is the second, and 6 is the third. Okay. So let's try these ones here, guys. For each of the following, state whether it's a monomial, binomial, or trinomial. So what do you think this one is? Okay, how about this one? And how about this one here? Oh, I thought I put the answers there. I guess I didn't. Okay, so this is a binomial. We have 1 term and a second term. This is a monomial. They're all multiplied together. And this is a trinomial. 1, 2, 3. Again, separated by the plus or the minus. Okay, so let's look at the topic of arranging polynomials by their powers. And when you talk about going up or down the stairs, you know, if you're going up the stairs, you say, I'm ascending the stairs. Of course, you probably don't say that, right? You don't say, hey, Mama, I'm ascending the stairs now. But if you did, maybe you do, hey? So you can go up the stairs, ascending, or down the stairs, descending, right? So we're going to look at arranging the terms into both ascending and descending order. So ascending is going from the smallest exponent to the largest exponent. So this is ascending order. And when you have the number 1, remember that's really x to the power of 0, because anything to the power of 0 equals 1, right? Okay, so you can see that the exponents are going up. They're ascending or ascending. Descending, the exponents are going down, and you can see that's the case here. Okay, so let's try a few more and see if you got this. So let's arrange these into ascending order. So I know I keep switching, guys. Sometimes I say ascending and sometimes ascending. It's like envelope, envelope. I don't know what you guys say, but so what do you think? What is this in ascending order? Okay, and how about this one here? Sorry, I forgot to mention, this should be ascending powers of x. So we're only focusing on powers of x. And the same with this here. This is descending powers of x. So again, when we arrange them, we just focus on the powers of x. Okay, let's check out the answer. So this was ascending order. And so we're going up. So this 5 is really like x to the 0. That's the smallest. This x is just x to the 1, right? And this is x to the 3. Okay, and I wrote that here. So you can see that they're going up. So that's ascending order. Let's look at the next one that involves descending order. Excuse me, guys. So here you can see that it's x to the 4th, then it goes down to x squared, then it goes down to x to the 1. Okay, now the one that was x to the 1 was just originally x, but that means the same as x to the 1. Okay, so you can see that those are going down in descending order. Awesome. Also remember that you can rewrite polynomials and they mean the same thing, right? So you can take this here and you can rewrite it so that these terms are in order. And it means exactly the same thing. So remember that. Now we're going to look at parts of an expression. Okay, so there's different parts that make it up. Of course, we know what the variable is. That's the number and it stands for something, right? And the other numbers are the coefficient and the constant. Now the constant is just a number by itself. Okay, so it's actually the -3 here. It's not just the 3, it's the -3. Okay? So that's the constant. The coefficient is always a number that's in front of a variable. Okay, so remember the difference between those two. And together, they are terms. And they make up an expression. Okay? So here, you can see 5 is the constant, 10 is the coefficient. So again, the coefficient is the number that's multiplied by the variable. It's really 10 times p. Okay, so we're going to look at evaluating polynomials. Let's think of what the word evaluating means. So when we evaluate something, we determine what its worth or value is. So if you filled out a survey, you'd be filling out a survey basically to indicate what the value of something is. You know, if you liked the product, or didn't like a product. So maybe you've seen on TV sometimes they have these shows where people look at these old products and, you know, antiques and so on, and they appraise them. So people who appraise things find out what the worth of something is. So when we evaluate a math expression, we determine its value, or we're getting an answer for the expression, right? Okay, so I'm just going to read a few things. So evaluating a math expression means finding an answer for it. We use substitution, that math skill, to find the answer. We substitute the value of the variable into the solution. Okay, so for example, if our expression was 3x, and we were told that x equals 5, we plug in that 5 every time we see an x. So because it means 3 times x, it means 3 times 5, and that is 15. Okay, so if you think about sports sort of terminology, yeah, when you're talking about substitution in soccer, a substitute player takes the place of another player. Okay, so when we're doing math, numbers are taking the place of variables. So you have 4x cubed. If x is 2, that becomes 4 times 2 cubed. Okay, so we put that 2 in and we put brackets around it. And now what we can do is basically expand the 2 cubed, and that's 2 times 2 times 2. We keep it in brackets, so it's 4 times that. Now we make it 4 times 8. You can write it out this way now. 4 times 8 is 32. Okay, now let's evaluate 3ab, where a is 2 and b is 3. So it's a to the power of b, so it's basically 2 to the power of 3. Okay, so 2 to the power of 3. So we write that out. 2 times 2 times 2. We keep it in brackets. That's 8. And so we're multiplying 3 times 8. That gives us 24. Okay, try this one. I'll just give you a few minutes to try this one on your own and see what you get, and then we'll go over it on the next page. So just think about it in your head. I'm multiplying 4 times that -2, and then I'm adding 5 times that -2, which is squared. Okay, so when I'm multiplying the 4 times the -2, just looks like that. The 5 times the x squared, because x is -2, it's 5 times -2 squared. Okay, so 4 times -2, that eventually becomes -8. -2 squared is like -2 times -2, which becomes 4. So 5 times 4 gives us 20. So we have 20 minus 8 gives us 12. Okay, so that's one example of substitution. Then also, of course, we can have substitution in a problem, right? This one says the diver takes a step off the diving board. The time in seconds it takes to hit the water is related to the distance in meters from the diving board to the surface of the water. The formula we're going to use is this one. And it says if it takes the diver 0.6 seconds to hit the water, the distance from the board to the surface of the water is how many meters? Okay? So we need to find out what the distance is, because we're needing to find meters, right? So to find distance, we need to plug in the value of t, and then we'll find distance. So what are we going to put in the blank for t, which is the amount of time? Well, it's given in the question as 0.6, so we plug in 0.6. Instead of t, we plug in 0.6. Okay, so there you can see instead of having 4.9 t squared, we have 4.9 times 0.06 squared. We do the math, which gives us 0.36. Multiply that by the 4.9 and get this as an answer. If this said round to the nearest hundredth, we would round it to 1.76 because these are tens, these are hundredths, and because this is less than 5, we keep it at 1.76. As you can see, this question said round to the nearest hundredth. So remember, it's different than saying round to the nearest hundred. It's saying round to the nearest hundredths, right? Okay, so the next one here is another evaluation one. This one's a little more tricky, actually. So we need to keep track of some negative numbers here. So b is 1 and c is -2. So we plug them in here, and you can see the math that's going on here. You can see in this bracket, so you have -2 minus 1, so you got a negative number, and you're going even more negative. That's -3 you're going to end up with here, -3 squared. Let's look at what happens here. You have 1 minus -2. When you have two minuses in a row, that's like a plus. So it's 1 minus -2 is like 1 plus 2. Okay, so now we have in the brackets 1 plus 2 squared. That's the same as 3 squared. Okay, so by the time we've done all the math on the left bracket, we have -3 squared. On the right bracket, we have 3 squared. -3 squared is like -3 times -3. A minus times a minus gives us a plus. We have 9 on the right. 3 times 3 gives us 9. So we've got 18 as an answer. This is a really good one to practice to make sure you can keep track of the negative signs. Okay, let's look at adding and subtracting polynomials. Remember when we added and subtracted fractions back in the day? Of course, we always wanted to find common denominators to be able to add the two fractions. Kind of similar in this situation. Here we have to have like terms to be able to add them. So in order to be able to add or subtract polynomials, we need to add like terms to like terms. So here's some examples. 4x plus 3x is 7x. 4xy plus 3xy is equal to 7xy. 4x squared plus 3x squared equals 7x squared. But here are some examples where we can't add or subtract because we have unlike terms. So we can't add 4 plus 3x. It can't be done. 3x plus 3y can't be done. And 3x plus 5x squared can't be added together. Okay, so let's try out these rules. We have -2x plus 5x. What do you think that's going to equal? Well, we can switch them around and make it 5x minus 2x, and that equals 3x. How about the next one here? 3xy plus 4xy, and we have a plus minus 5xy. Okay, so 3xy plus 4xy is 7xy, and the plus and the minus just equal minus 5xy. So 7xy minus 5xy is 2xy. Okay, so for this next one, we have 2x plus 3y plus 4x. So we group the like terms, we group the x's. So we have 2x plus 4x, and then we have plus 3y. 2x plus 4x is 6x, and then we have the 3y. Those two can't be added, so that's our final answer. Next one here. Okay, we can see we're going to group the like terms, so we group the minus 5p and the 4p. So that becomes 4p minus 5p, that's minus p. And then we have plus 2 and plus 3 is plus 5. So that could be our final answer, minus p plus 5, or we could make it 5 minus p. Okay, when we have this sort of example here, when we've got some brackets, we add the 5x squared plus the 2x squared. That gives us 7x squared. You can see I put them in the same color. I put the x's together. 2x plus 8x gives us 10x. The numbers, 3 plus 10, gives us 13. So that's our final answer. Okay, here's an example when you have something like this. If it was written out just like this, this really implies that we're subtracting not just the x squared, it implies we're subtracting everything on the bottom line. So what we should do in the next step is to put brackets around everything on the bottom. And then we have to distribute. Remember, this is like a -1. So we multiply the -1 times the x squared, -1 times the 2x, and then -1 times the 1. When we do that, we get this here, -x squared minus 2x minus 1. So now we can rewrite the original question by putting this on the bottom. And once we've done that, then we can do the math. Because we have 3x squared minus x squared is 2x squared. 5x minus 2x is, sorry, that shouldn't be minus 3x, that should be plus 3x. Sorry about that. And then 3 minus 1 is 2. Okay. So moving along, now we're going to look at a few questions that involve problems again. So this one says a particular lot has the dimensions shown below, and so it's asking us for the perimeter. So of course the perimeter is always the distance around the edge of any shape, so we add all the 4 sides together. So basically we're adding all these expressions together. So let's see what that looks like. Okay, so here's all the expressions. I kind of spaced them out. Of course, we want to group like terms, so we put all the x values together. Here's all the x values put together. Here's all the numbers put together. And then we can do the math. 2x plus x is 3x, plus another 3x is 6x, plus an x is 7. And minus 1 plus 6 minus 5, that all gives us 0. Okay, so 7x plus 0, in other words, just 7x is going to be the answer, and so the answer is going to be D. Okay, we're going to look at this point at multiplying and dividing polynomials. Okay, so that's a new kind of a topic from dividing, or rather adding and subtracting. So we already know this. Mono stands for 1 by 2 and all that. So we're going to look at 3 different types of multiplying of polynomials. The first one is when we multiply monomial times monomial. You can see that's an example there. Then we're going to look at multiplying monomials times polynomial, and we put the polynomial part in brackets, and then I'm sure you can guess that we're going to have to use the distributive law. And the last one is going to be multiplying binomials times binomials, 2 times 2, and we use a special type of acronym, which is FOIL, and we're going to go over what FOIL stands for. So whenever we multiply binomials times binomials, we use FOIL. Okay, let's look at multiplying monomials times monomials. We want to multiply number times number and variable times variable, and then add the 2 answers together. So 2 times 3 gives us 6. Then variable times variable, p times p gives us p squared. And then we put the 6 beside the p squared because it's multiplied together. That gives us 6p squared as our answer. Okay, so again, we multiply number times number, variable times variable, and put the 2 answers together. Okay, so let's think about this one. Okay, when we multiply number times number, 3 times minus 5 gives us minus 15. Now the x squared times x is like, remember x squared is like x times x, and then we're multiplying by another x, so that gives us 3 x's multiplied together. So it gives us x cubed. And the y squared still stays there on its own, so it's x cubed y squared. Okay, so we got these 2 answers, and again we put them together to get our final answer. So when we multiply monomials times polynomials, that's the next thing we're going to look at. We use the distributive law. Okay, so distributive law says multiply the first term by the first term in the brackets, first term outside by the first one inside. Then we multiply the term outside by the next term inside. 6 times 2x, 6x times 2x is 12x squared. 6x times 8 is 48x. So let's try this one. What are we going to get when we multiply 2p times 2p? Okay, how about 2p times t? And how about 2p times minus 2? Okay, so 2p times 2p, the 2 times 2 gives us 4, p times p gives us p squared. So we get 4p squared when we do that math. 2p times t gives us 2pt. 2p times minus 2, the numbers give us a minus 4, and then we multiply that by p, minus 4p. So that's our answer. All right, so let's look at the last situation where we're multiplying two binomials together, and again, we always use FOIL. So what does FOIL mean again? Well, the F means multiply the first terms, and first is always going from left to right. So this is the first in this brackets on the left side. It's multiplied by the first in this brackets on the left. Then there's outer. So you can see those are outer on the outside of each bracket. If you take your hands and put them as far away as possible, that's what I always imagine for outer. Inner. Okay, you can see why that would be inner. If you put your two hands together, close together, that's inner. Multiply those two together. And then last, again, moving from left to right, last is on the right. So we multiply 3 times 5 when we multiply the last ones. So let's see how we actually do that then. So if we've got these two being multiplied together, when we're multiplying the first ones, that's 2 times x. That gives us 2x squared. Then we multiply outer first. Okay, so again, these ones are outer. 2x times 1 gives us 2x. Then we look at the inner ones. That's 5 times x, gives us 5x. Then the last, on the right side of each bracket, 5 times 1 gives us 5. And then we add all these things together to get our answer. You can see that only the x values are going to be like terms, so 2x and 5x is going to give us 7x. So we end up with 2x plus 7x plus 5. And you can see the math here. Okay, so that's our final answer. So we collect all like terms, like we've done here, like terms, and then simplify. All right, so let's look at a different one here. If you have 2x plus 5 and that whole thing squared, it means the same as 2x plus 5 times 2x plus 5. And then again, when we use FOIL, 2x times 2x is 4x squared. Then 2x times 5 is 10x. And then 5 times 2x is 10x. And 5 times 5 is 25. And we simplify the 10x plus 10x gives us 20x. And there's our final answer. Okay, so let's try this one here. And I apologize, I'm probably not really giving you enough time to try these on your own, so try them again later. Just don't want to leave too much of a lull in the recording here. But when you do this, you should get this as the final answer. Okay, x squared minus x minus 1, because we have 2x minus 3x becomes minus x. Okay, right on. So let's look at a problem that involves FOIL. And so what we have here is a situation where a home builder is installing a new carpet, and the area in square meters is given by this trinomial. And it also tells us that one of the lengths is given by x minus 3. So we have to find the missing length. And how do we do that? Well, of course, since we have a rectangle, we use the area of a rectangle. The area of a rectangle we know is area equals width times length. So if we call this one length, we have to find the width. So first we write that out. Width times length equals area. We know the area, so we put it below. We know the length, so we put it below. We don't know the width. But we do know that the width is going to be a binomial. And why is that? Because a binomial times a binomial equals a trinomial. In other words, width times length equals area. So whatever the width is, it's going to be some binomial. Now in this question here, it gives us possible binomials. And we need to try each one of them and multiply it by this binomial to see if we get this trinomial. When we do, we'll find out that A is the correct answer. Okay, so if you multiply minus 5 times x minus 5 times x minus 3, you should get this here. Okay, so here you can see the setup here, like this. And when you do the actual FOIL, it's going to look like this. And in fact, it actually does equal the trinomial. Okay, so now we've been talking about multiplying monomials and polynomials. And at this point, we're going to divide polynomials by monomials. It's important when we're talking about dividing to just remind ourselves about certain math terms that go along with dividing. Remember that the dividend is the answer. The dividend is the term being divided, so that's the 18. The term which the dividend is divided by is the 3, so that's the divisor. And 6 is the answer to a division question. So the answer to a division question is the quotient. Okay, so remember those different words. But let's look at two different types of division questions. One is dividing monomials by monomial. Sorry, it's hard to say that sometimes, guys. The other is dividing polynomials by monomials. Okay, let's see how to divide polynomials, or rather monomials by monomials. So here we have a monomial and another monomial. And you can see that what we really want to do is think of it as the numbers forming their own fraction and the variables forming another fraction. Now the only reason I put them so far away is so that I could show the math and not have it all cluttered up. So the 6 over 2 is 3. M squared over m gives us m. And we'll see why that is in a sec. But what you do then is you put the two answers together. 3m is our final answer. Okay? So we're dividing number by number and variable times variable and putting the answers together. Okay? So when we divide the numbers, we get this, the variable's this, and we put them together. So looking at it in a slightly different way, as far as how we get the answer m squared is equal to m times m, and then we have m on the bottom. So we cross off the m's that are in common, because anything divided by itself equals 1. So those m's get canceled right out, and it leaves us with m. We could also use the power rules, right? Because we subtract m to the 2 minus 1. Okay, so that's why 6m squared over 2m equals 3m. So you could also have a problem like the one we looked at before, where you've got an area given by this monomial, and then a length, and we've got to find the width. Okay, so this one's kind of similar to that other question we looked at. We know that area equals length times width. So here's area. It's equal to length times width, right? So this is our formula. 6m squared equals 3m times w. Now, if this was our formula, and we wanted to find what w is, what the width is, we would divide both sides by 3m, so we could get w by itself. And so we're dividing 6m squared by 3m. So this part here is the actual part that's dividing a monomial by a monomial. So that's why I'm showing you this example. So 6m squared divided by 3m equals 2m. And again, we divide 6 by 3 gives us 2, m squared divided by m gives us m. Okay, let's look at a little more complicated one. Again, we want to kind of break up the different parts to be able to think of them that way. So the numbers here, -8 over 12. We could divide 6 into each one, and that gives us -3 over 2. Now when we have x to the 5 over 3, that gives us x to the 2 over 1. Okay, if we're thinking of exponent rules, it's x to the 5 minus 3, which is the same as x to the 2, or it's y to the 8 minus 2 gives us y to the 2. Okay, so then our final answer, you can see that we're only going to have 2 on the bottom because these 1's just get multiplied by the 2. We multiply these 3 terms and get this on the top. So that's going to be our final answer. So practice these and see if you can get that. Here's another way of looking at the last one. I've just changed the x's and the y's, and the reason I did that is because you're multiplying, a times a. If you were multiplying x times x, the times looks like the x. So that's why I just switched that here. And I just wanted to show you, instead of using exponent rules, you could do it this way. You have a to the 5, so that's 5 a's being multiplied together. On the bottom you have 3 a's being multiplied together. So what you do is you cross off all the a's that are the same on top and bottom. So there's 3 a's on top and bottom. Cross those off, you're left with 2 a's. So that's why you're left with minus 18a squared. A times a is a squared. Same thing with the b's. You cross off what's in common, and you're left with b times b, or b squared. So you're left with minus 3a squared b squared. So just a different way of thinking of the multiplication there. Instead of using exponent rules, we're just multiplying out all the a's and b's. Okay, so here's another one to try. Think about what you think the answer would be for the numbers and the exponents, for the c's and the b's. Okay, so 8 divides into top and bottom to give us minus 4 over 3. 5 minus 2 gives us 3, c to the 3. 7 minus 3 gives us b to the 4. So that's our final answer. All right, we're getting there, guys. So now let's look at dividing polynomials by monomials. Okay, polynomial, monomial. So what we can do in this sort of a situation is to think of it as 8x to the 3 over 4x plus 12x squared over 4x minus 24x over 4x. In other words, it's kind of like a plus b plus c over d. Think of it as a over d plus b over d plus c over d. If you're thinking of it in terms of numbers, if you had 8 plus 12 over plus 16 over 4, it's like 8 over 4 plus 12 over 4 plus 16 over 4. And you can see how you'd get an answer for each one of these and then add them together. Okay, so same thing, it's just one is numbers, the other is variables. Okay, so back to our question we had here. Let's see what we get. So we put this 8x cubed over 4x, make that one fraction. We make 12x squared over 4x into another fraction, and we make minus 24x over 4x into the last fraction. And so then when we simplify it, you can see that this simplifies to 2x squared. Okay, this here, 12 divided by 4 is 3. X squared over x is x. Okay, in this situation here, you can see we have x's on top and bottom. They cancel out entirely. Minus 24 divided by 4 is minus 6. We add these three things together, and that's our final answer. Okay, so remember earlier we looked at a problem where we had a calculation involving monomial divided by monomial. Now we're going to look at a problem type question that involves polynomial divided by monomial. Okay, so if we have an area where we have a polynomial and we've got a width that's a monomial and we need to find the length, how are we going to do that? Well, think of it this way. It basically is represented by area equals width times length. And so if we want to find out what length is, remember that's what we want to find, We divide both sides by width, so length is equal to area divided by width. So that's basically what we're looking at. Length is equal to area divided by width. So take that formula, and when you look at it, we're dividing area by width. So we're dividing this polynomial here, these three terms, by this one term. And that's what you can see here. Okay, so we've taken area divided by width. That's this trinomial divided by this monomial. And when you do the math, it comes out to this here. So again, this is basically the same question as before. It's just put into a problem form. So length is this amount. Okay, let's try this one here. So again, we divide everything into its own little fraction. And we can see the math here. 18 divided by 3 is 6. Y to the 4, it's like 4 minus 2. That gives us 2. 15 divided by 3 is 5. Here we have 3 minus 2 gives us 1. It's just y. Here we can see the y squareds cancel out, and we're left with just minus 3. So that's our final answer. And I do believe we're done. So guys, again, practice all these glue questions. Make sure you can get them all on your own. As you know, I tend to make the questions on the test very similar to the ones we cover in these sessions. So if you practice them all, you can definitely go into the test with a lot of confidence. So do that practice and look at it as kind of a pre-test so you know yourself which ones you still need to work on. And if you need to work on some, and even if you need to get some more help, you can get some more help on those. And you can do well in the unit test. So again, unit test is the last week before the holidays. And so keep working hard, guys. You're doing a great job. Keep it up, and God bless, and have a great day. Bye for now.